Welcome everybody to example 3 of our ratio and root test. So here in this case, again, we're asked to determine if the series is going to converge absolutely, if the series is going to diverge, or if the root test is going to be inconclusive in this case. So let's take a look at what the root test is actually saying. So our root test is actually pretty similar to the ratio test, at least in the conclusions, but we're looking at a slightly different limit in this case. Here we're looking at the limit as n goes off to infinity of the nth root of the nth term. And so our conclusions are really kind of the same. If the value that we get out of that is going to be either between 0 and 1, then our series is going to converge absolutely. If our limit is going to be greater than 1, or if the limit is infinity, then the series is going to diverge. And if the limit is 1, then the test is inconclusive in that case. And so with that in mind, let's take a look at applying the root test. So we want to look at the limit as n goes off to infinity of the nth root of the absolute value of our nth term. So we have 5n plus the natural log of n raised to the n power divided by 5n raised to the n power. And it's with this that we really begin to see, well, why would we choose the root test for this to begin with? Because our terms are naturally raised to an nth power, that seems a logical choice to simplify our algebra a lot. We get rid of that nth root. So the nth root kills off the nth power, and so we just have 5n plus natural log of n divided by 5n. Well, if we do a little more algebraic simplification on that, we have the limit as n goes off to infinity. We divide everything by 5n, so we get the natural log of n. Let's fix that. The natural log of n divided by 5n. And we're looking at the limit as n goes off to infinity. Well, the first term, what happens as n goes off to infinity, our 1 really doesn't do much. It's just a constant, so we have the limit as n goes off to infinity of the natural log of n divided by 5n. In this case, n goes off to infinity, so natural log goes off to infinity. N goes off to infinity, so we end up with, in this case, an infinity over infinity indeterminate form, which we could fall back to L'Hopital's rule in the continuous case and see exactly what's going to happen in that case. So what we're interested in is the limit as x goes off to infinity of the natural log of x over 5x. Well, applying L'Hopital's rule to that, we look at the ratio of the derivatives, limit as x goes off to infinity, so we have a 1 over x divided by 5. Which we can simplify to the limit as x goes off to infinity of a 1 over 5x. Well, as x goes off to infinity, that's going to give us a value of 0. And so what happens then with our limit as n goes off to infinity of the nth root of our a sub nth term, we get 1 plus 0. Which in this case we get a value of 1, and so that tells us that for the root test, that the root test is inconclusive. And so we would have to do some other test if we were really needed to know whether this series is going to converge or diverge. So I'll see you guys in the next example.